ladies and gentlemen, welcome back. We're going to jump right into it. We're going to start balancing our redox reactions using this half reaction method. So you should at this point be able to identify, hey, what's oxidation, what's reduction. Just write out those half reactions, identify the number of electrons that are transferred, and at that point now we can move into actually balancing those half reactions so that we can total them back up and get an overall balanced redox reaction. All right. I'm going to give you the rules first, and then we're actually going to make sense of the rules as we do a couple of problems together. The rule number one, you need to identify your oxidation and your reduction half reactions. All right? So identify the reactions out. Second thing, the number of electrons lost needs to equal the number of electrons gained. There has to be that conservation, right? Law of conservation of insert whatever thing you want to put in there. Nothing be created or destroyed. I can't lose or gain electrons from nothingness, all right? So electrons lost need to equal electron gains before we can add them together. Third thing, we are going to use water to balance out the oxygens. And then the fourth rule, we are going to use H+, the hydrogen ion, to balance out the hydrogens. I know you don't understand those. It's okay. Let's go ahead and get started. I'll make some sense of them for you. Okay, so there's my first reaction. It's going to be a simple one here to get started. So let's take a look. The first thing, again, I want to assign my oxidation numbers. That's 0, that one's +1, that one's +2, and that one's 0. So that's pretty simple. I'm looking at zinc. This is my oxidation. My hydrogen is my reduction. So I'm going to go ahead and write those out. I like to draw my arrows when I do these so I can put them in the same spot. So my oxidation, let's see, that was hydrogen. So I'm going to do H+ going to, oh wait, that was my reduction. Sorry, I'll do that down here. So H+ plus an electron going to H2. Now remember, those diatomics, they do that funky thing where I need to double this to balance that out, make sure I've got the proper number of hydrogens. And now let me go up and actually do my oxidation. Thank you very much, Mr. Doolin, while you confuse us while we learn something new. And then 2 electrons there, right? Because the difference in my oxidation numbers was 2 there, I knew that was 2 electrons. Now, I identified my half reactions. I wrote them out. Now remember, at this point, I'm looking for oxygens and hydrogens that don't balance. I don't have any. Now I need to make sure these are the electrons I was talking about here. They need to equal so that they can cancel out, right? Remember spectator ions from writing my net ionic equations. These are spectators. They appear on both sides in the same way, so they are actually going to simplify and cancel out. So I would end up with Zn plus 2H+ is going to give me Zn2+ plus H2. I know. I get it. Some of y'all are looking at this going, I could have done that in my head. No, I know you could have done it in your head. It was an easy one. I need you to get used to looking at those electrons, all right? Let's do another problem. All right, so my next one here, I see another skeleton equation, or what you would think of as a net ionic equation, ladies and gentlemen. We are not, primarily, we're not going to be dealing with molecular equations. We'll be looking at net ionic equations when we're dealing with redox reactions, so please get used to it. I know the practice that we did in identifying half reactions was molecular equations. Again, that's just because you're used to and comfortable with seeing molecular equations. Most of what we're going to see here is ionic. So here we go. Let's assign some oxidation numbers. That one's a -1. This one's a +4 for that nitrogen. Oxygen's -2. My iodine here is 0. This nitrogen's +2, and oxygen is -2. So again, identifying nitrogen here and iodine there. So my iodine's becoming more positive. It's oxidized. It's losing electron. And nitrogen, its charge is decreasing, so it's being reduced. So again, let's come down here. Let's write these out. All right. Draw my reaction arrows there. And so my oxidation reaction, let's see if I can get this right this time. So I'm going to go I- going to I2 plus an electron. Now, again, because the difference here is -1, but remember with my diatomics, I got to do this funky thing, right? Where I double that. So I got 2 electrons lost there. My reduction, this is going to get a little funky here. I'm going to go ahead and erase that. So I'm going to start out with, I've got NO2. I know I'm going to gain 2 electrons in this particular case, right? Because the difference from plus 4 to plus 2, and then I'm going to NO. Now, what most people see here is my oxygens are not balanced. We ran into this before. The rule I gave you beforehand was we will use water to balance out the oxygen. So, on my product side here, I'm only going to add 1 water because here on the reactant side I got 2 waters. Here on the product side I only have 1. I only need 1 more. Now the problem that I've created is that my hydrogens are not balanced. Well, what was the 4th rule? I'm going to use the hydrogen ion to balance out the hydrogens. So over here on the reactant side, I would put 2H+. Now my hydrogens are balanced out again. Now I am okay. One thing I want you to notice is that the charges of each side of these reactions are equal. The charges have to balance, all right? Okay, so now what I'm going to do, again, my electrons are equal, so once they're equal, I can go and add these together and cross those out. So now I get 2H plus 2I minus plus NO2, giving me I2 plus NO plus H2O. Notice, a little bit more complicated. We started adding some ions in there, right? Okay, so here we go. We're going to do another example, the last one. All right, so there's my last equation here we're going to be working with. Let me go ahead and assign oxidation numbers. Manganese here is a +7. Oxygen's -2. Oxygen never changes. So then chlorine's -1. My manganese over here is +2, and this chlorine is 0. So let's go ahead and write out our oxidation. My oxidation, let's see, chlorine was oxidized. So Cl- going to Cl2+. I'm going to go ahead and put 2 electrons here. It's a diatomic. I caught that. And then for my reduction, whoa, here we go. We want that back up. For my reduction reaction, let's go ahead and put MnO4-. And don't forget those charges, ladies and gentlemen. They are important. And let's see, I'm gaining 5 electrons there. The difference of +7 and +2. And then I'm going to Mn +2 on the product side. Now, I look at the first one. I'm good and kosher. No oxygens, hydrogens. I'm good. The next one, the MnO4, that reduction reaction. I'm looking here. I've got some oxygens I need to balance out. And so let's go ahead and get to it. I'm going to add 4 waters over there because I've got 4 oxygens in my reactant side. And now I've added 8 hydrogens over there. So I'm going to do 8H+. Now, here's the next funky thing with this one. My electrons are not equal. Remember, electrons lost need to equal electrons gained. So I am going to have to multiply these reactions. So this first one, I am going to multiply times 2. Or I'm sorry, times 5. Multiply times 5 there. Because the least common multiple here between 2 and 5 is 10. So that would give me 10 chlorines. 10 Cl2, actually that would be 5 Cl2s, I'm sorry there, 5 Cl2s, and then it would give me 10 electrons over here. The bottom one, I'm actually only going to multiply by 2, because again, I'm trying to get these electrons equal. So that would be 10 electrons, that would be, I keep on hitting that with my wrist, that would be 16 waters, that would be 2 MnO4, 10 electrons, 2 and 8 waters over there. All I did was multiply the coefficients. Now I am actually ready to add all this together. My electrons actually cancel out, so now you notice why I keep my arrows lined up so I can see what's on the reactant side, what's on the product side. So I'm going to have 16H plus 2 MnO4 plus 10 Cl minus. And then I do 5 Cl2 plus 2 Mn 2 plus 8 H2O, and there I am, my balanced redox reaction. Aren't those little hairy electrons fun? Okay, so hopefully you got some questions there. If you do, write them down, bring them to class, we'll get them taken care of, or you can come to tutorials and get them taken care of there. Otherwise, I will see you in class.